So that the points A, B and C are collinear. Okay. So to solve this problem, get the direction ratios of AB. I am not writing the vector AB, simply I am writing direction ratios of AB. Means you get by doing OB minus OA. OB minus OA in B we have to subtract. 2 minus 1, 1. 6 minus 2, 4. 3 minus 7, minus 4. And the direction ratios of BC. BC means in C subtract B. In C subtract B. 3 minus 2, minus 1. 10 minus 6, 4. And minus 1, minus 3. 3 minus 2, C minus 1. 3 minus 2 is 1. 10 minus 6 is 4. And minus 1 minus 3 is minus 4. So, direction ratios of AB and direction ratios of BC are proportional. Once the direction ratios are proportional, we conclude AB and BC are collinear. Once the vectors are collinear, these vectors are formed by the points A, B and C, and the points are collinear. Yeah. If either A is 0 or B is 0, then definitely A dot B is 0. See, A dot B definition is magnitude A, magnitude B, cos theta. If either A is a 0 vector, A is 0 vector means the magnitude of A is 0, when the product becomes 0. Definitely A dot B is 0. If B is a 0 vector, its value is 0, again 0 into this value is 0. No doubt about it. If either A is 0, B is 0, then A dot B is 0. But the converse need not be true. It means, converse means what? If A dot B is 0, then it is not necessary that A is 0 vector or B is 0 vector. Justify your answer with an example. So, give an example to show the converse of this. Means, give an example to show where A dot B is 0, but A is not equal to 0, B is not equal to 0. So, we construct example like this. I plus 2j plus k. Note here how I choose the vectors. I plus 2j plus k. Keep in mind that A dot B must be 0. A dot B must be 0. So, B I choose like this. I minus 2j plus k. See, this is our choice, and in choosing B we have to be careful. When you take the product, dot product, it is 1 into 1 plus 2 into minus 2 plus 1 into 2. Observe, see, this is 1, this is minus 4 and this is plus 2. Definitely this is not equal to 0. So we do not need such example. We have to take B such that the dot product T must be 0. So I choose like this. I plus J, note here. 1 into 1, 1. 2 into 1, 2. 1 plus 2, 3. Now make sure that whatever the number you take in the next, when you take the dot product, the total A dot B must be 0. Now, when you take the product, it is 1 into 1 plus 2 into 1 plus 1 into minus 3. Okay, what is it? 1 plus 2 minus 3. So, 3 minus 3 is 0. A dot B is 0. A dot B is 0. Note, A is not a 0 vector. 0 vector means its magnitude must be 0. Here, if you take the magnitude of A, it is root of 1 plus 4 plus 1. So that is magnitude of A is root 6 and magnitude of B is also root 6. Clearly, these are non-zero vectors. A is not equal to 0 and B is also not equal to 0. B is also not equal to 0. So this is an example for A dot B is 0, but A is not 0, B is not 0. Or the simplest example we can give like this. Take A equal to unit vector I, B equal to unit vector Z, and when you take the dot product A dot B, I dot Z, which is a 0 because I and J are perpendicular vectors, but I is a non-zero vector and J is also non-zero vector. Give any such example. See what happens. If A dot A is 0 and A dot B is also 0, then what can be concluded about the vector B? Okay, what is given? A dot A is 0. A dot A is nothing but magnitude A square is 0. Magnitude A square 0 means magnitude A is 0. Magnitude A is 0 means A is a 0 vector. A is a 0 vector from this condition. A dot A equal to 0 means A is a 0 vector. Then see what is that? A dot B is 0. That's also given. A dot B. Here, already we are sure that A is a 0 vector. Once A is a 0 vector, for any B, definitely A dot B must be 0. I repeat, since A is a 0 vector dot any vector, not only B, you can take C, D or vector X. Since A is a 0 vector, A dot B, definitely it is 0. What is the question? What can be concluded about the vector B? Once A is a 0 vector, you take any B, definitely it is 0. So conclusion is B can be any vector. Okay, or only this answer is enough. Since A is a 0 vector, B can be any vector. The next question. Okay. Magnitude A is root 3, magnitude B is root 2, and angle between A and B is 45. See what is given here. Magnitude A is given, magnitude B is given, theta is given. These three are given, A dot B is asked. Now use the formula which connects magnitude A, magnitude B, theta and A dot B. So we know this formula. A dot B equal to connect these three. Magnitude A, magnitude B, cos theta. Okay, what is magnitude A? Root 3. Magnitude B, root 2. Cos 45. So cos 45, that is root 3 root 2 and it is 1 by root 3. So this and this cancel, you get root 3. Answer for this is root 3. And note here we have not used this. Actually for A dot B, magnitude A, magnitude B, cos theta, one definition. Another one is A1 B1 plus A2 B2 plus A3 B3. Now you cannot use this second one because we do not know what are A1, A2, A3 and B1, B2, B3. So we have to use the first definition, magnitude A, magnitude B, cos theta. Use it, magnitude A, magnitude B, cos theta, get the answer. So again it is was asked in question. It is asked A and B represents diagonals of a rhombus. Diagonals of a rhombus. A and B represents diagonals of a rhombus. You know, rhombus is a figure like this. Okay. And you know one of the property. Here A is one vector, A is one diagonal, B is another. And in a rhombus, what happens? Diagonals are perpendicular. A and B are diagonals. Therefore, A dot B must be 0 because they are perpendicular vectors. See what is given and what we have to do. Here, if A is a non-zero vector of magnitude A, what is given? A is a non-zero vector of magnitude A. A is equal to A. Note here, this is vector A and this A, it is a scalar which represents magnitude of A. And what is given? We have to find the value of that A. That means we have to find magnitude of A if lambda times A is a unit vector. This is given. Lambda times A is a unit vector. Lambda A is a unit vector. Is a unit vector. So unit vector means its magnitude must be 1. But how we take it is lambda times magnitude A equal to 1. So lambda times what is magnitude of A here? Small a, this is given, is equal to 1. Then what is asked? A is asked. So therefore A is equals to 1 by lambda. Here is magnitude lambda or absolute value of lambda into A is equal to 1. Lambda magnitude of A is equal to 1. That gives A equal to 1 divided by magnitude of lambda. See here, why I have taken this lambda times A. Suppose A is this vector. A is two I plus 2j plus k. If I take 2a or minus 2a and minus 2a, see what it is. 2a, it is 4i 4j plus 2k, minus 2a is minus 4i minus 4j minus 2k. If you take the magnitude of 2a, it will be 16 plus again 4 square, 16 plus 4, that is root 36. And if you take magnitude of minus 2a, it is again minus 4 square, 16 plus 16 plus 4, root 36. So magnitude cannot be negative in both the cases. This is. So therefore, the magnitude of 2a or magnitude of minus 2a, they are same, but 2 and minus 2 are different. So that is why I write it is absolute value of 2 times a. So that is why magnitude of lambda a, I write absolute value of lambda into magnitude of the vector a equal to 1. So absolute value of lambda and magnitude of the vector a is a, this is given. So a equal to 1 by lambda. What is given and what we have to do. If a is a unit vector and x minus a dot x plus a equal to a, this is given. A is a unit vector, this is given. And one more thing, x minus a dot x plus a, is equal to 8. Now, I use this. X minus a is a vector x minus a dot x plus a is equal to 8. But what, see, we are in vector x minus a dot x plus a. It is magnitude of x square minus magnitude of a square equal to 8. Magnitude of x square, but magnitude a is 1, means magnitude a square is 1 square, which is also 1. Magnitude a square is 1 equal to 8. That gives magnitude of x square is equal to 9. That gives magnitude x equal to 3. Don't write plus or minus 3. If you write plus or minus 3, this is wrong, because magnitude of x, it is always non-negative. Magnitude of x is a positive quantity. So don't write plus or minus 3. You write only plus 3.